All right, so let's look at an example of converting data from one scale to a z-scale. And I'll show you how to do it also with your calculator. So here's an example of converting from a donut scale to a z-score scale. So you randomly selected 9 people and asked them the following question. If a box of donuts were placed in front of you, how many would you eat? So the data set of your sample answers are this. So one person said that they would take one donut. 2 people said that they would take 2 donuts. 3 people said that they would take 3 donuts. 2 people said they would take 4 donuts. And 1 person said they would take 5. So down below is a dot plot of the sample data that's shown in the figure here. So, one person would take 1 donut, 2 people would take 2 donuts, 3 people would take 3 donuts, 2 people would take 4 donuts, and 1 person would take 5. So we can enter this data into Texas Instruments and the Numworks calculator, and we can use that to convert from units of donuts into a z-scale. And we can do it with this equation. Now, here we were given the raw data. Right here. Here we have a data set. What we were not given is we weren't given the sample mean and we weren't given the sample standard deviation. Both of these things we need in order to do the z-scale conversion, right? This variable x is going to be each one of these values in turn. Those will be our values of x. So first we'll put in x equals 1, and that'll give us a z-score for converting x equals 1 into a z-score. And then we'll put x equals 2. And then we'll see what the equivalent z-score is for x being equal to 2 donuts. If we put a value of x equals 3 donuts, then we'll get a z-score equivalent to 3 donuts, and so on. So we'll put in 4 and we'll put in 5. Okay, so the first thing we need to do before we can do all of this is we need to calculate the sample mean and the sample standard deviation. So let's do that first. So here we are with the Texas Instruments calculator. So if we go into the list editor by hitting the Stat button, Edit menu, Edit option. So list 1, I put the list of unique datums in the data set. So this represents 1 donut, 2 donut, 3 donuts, 4 donuts, and 5 donuts. List 2 is the frequency. So 1 person wanted 1 donut, 2 people would say they would take 2 donuts, 3 people said they would take 3 donuts, 2 people said they would take 4 donuts, and 1 person said they would take 5 donuts. So we need to use one variable stats in order to get x bar and s, the sample mean and the sample standard deviation. So once you've entered this in, hit the Stat button, go to the Calc menu, and we want the 1var stats option. Okay, now list is going to be our list of unique datums. And for me, that was list 1. So you can see list 1 is not present here. So to get it, notice that L1 is above the number 1 key. So in order to get that, for me, L1 is in blue, which is a hint to me that I have to hit this blue second button first, followed by the 1 key to give me L1. Frequency list is the list of frequencies for each one of these unique datums. And for me, that was list 2. So I'm going to hit second and L2. And then I can come down here to calculate. Okay, So it told me that X bar is equal to 3. So the sample mean is 3. And then SX, this is the sample standard deviation, is 1.225 approximately. Okay. But technically, we shouldn't calculate with rounded values. So we're going to end up using, I kind of did a bad thing when I did this example. I used a rounded value and I shouldn't have. Okay. But I'm going to correct that in this video. All right. With the NumWorks calculator, what we want to do is go into the statistics app. And the statistics app is set up automatically to put in your unique datums, your unique values into column V1. And then the second column is the frequency column. Okay, this is column N1. So you can see, I had the same values that I had over here with the Texas Instruments. Now, in order to get X bar and S, then what I need to do is scroll up to these tabs. So now I have the data tab selected, move over to the stats tab and click OK. So now this is going to give me statistics on the columns of data here. So right now it's giving statistics of the value and frequency columns together, right? So number of data points. So n equals 9 because there were 9 people that I asked in this study. And what I want to go down is I want to go down till I get to sample mean. Okay, not population mean. I want sample mean, which is X bar. Now, for me, because I made this example, it comes out to an even 3. Okay, but what if your sample mean didn't come out to an even 3 and it was some, really long decimal number? Okay, then what I would do is I would store this in a variable, and I would choose a variable that represents the value it's holding. Okay, so what I'm going to do is I'm going to store this in capital M for mean. Okay, so how I do that is I want to make sure that the value I want to store is selected. And the store value button is, you'll notice that on this X to the Y key, there's this orange arrow. So because this arrow is orange, I need to hit the orange shift key first. So if I hit shift and then this key, okay, it says I want to send 3 into what variable? Okay, now I want to put that in a capital M. So notice that there's an M here above the 7 on this 7 key. So to make it a capital M, I need to hit shift, then the alpha key, and then 7. Okay, and so for me, I'm storing 3 in this capital M variable, which to me stands for the mean. All right, so now I'm going to hit execute, and it's done. The other thing we need is we need the sample standard deviation. So you can see it's 1.22475. We're getting the same values we got on the Texas Instruments. But I'm going to store this in a lowercase s. So again, I'm going to hit shift, this X to the Y key, okay, which means I'm going to take this and I want to store this. Now this will be a lowercase s. So S is here in the 5 key. So to get just a lowercase s, all I need to do is hit the alpha key. I don't need shift and alpha, just alpha and then 5. So notice that this is a lowercase s now, and I'll hit execute. Okay, so now we've calculated X bar and S. Now we've calculated X bar and S, we can now go about calculating our Z-score. So what we need is we need to create in our calculators an equation with this expression in it. So what we're going to do, I've kind of done things a little bit differently than what I've got in these screenshots. But in the example that I'm doing right now, list three is going to have all of my z-scores in it. And so I'm going to set list three to be equal to this equation. All right. But what I'm going to do is I'm going to use the calculator's functions, I'm sorry, variables in this. So um, right now it's going to be list three is equal to list one minus, and I'm actually going to put in an X bar, and then I'm going to put divided by SX. Okay. Over here with the numworks calculator, I'm going to go to the V2 column, and I'm going to say that that's going to be V1 minus my mean divided by my standard deviation. So this is kind of where I said I rounded and I should not have, because if you remember, this was 1.224 and it had a bunch of other numbers. I rounded it to 3 decimal places. By doing things this way, we're going to have a better calculation and one that isn't going to be thrown off by any rounding in our calculation. Okay. So let's go ahead and carry this out and let me show you how to do it. So on the Texas Instruments calculator, let's go to Stat. We need to get back to the list editor. So Edit menu, Edit option. And then here in list three, okay, now I want to type in this equation. So my z-score is equal to my value of x minus the sample mean divided by the sample standard deviation. I'm following this model. Okay, so list three is equal to, I'm going to put in parentheses, second and one, that'll print an L1, minus, now I need to put in X bar. So to put in a variable on the Texas Instruments, you want to hit this variables button. And then we want to go to statistics. We want to go to statistics variables. And notice number 2 is X bar. And notice 3 is going to be our standard deviation, our sample standard deviation. But we'll get to that in a second. So we're going to put X bar there. And so X bar is the value that we just most recently calculated. So it's going to put that in there. Okay, right parentheses, divided by our standard sample standard deviation that we just calculated. So I'm going to hit vars, go down to statistics, go down to the third option, which is SX. So this is sample standard deviation. Hit enter. All right, now as soon as I hit enter, let me leave that up. But as soon as I hit enter, it's going to fill list 3 with z-scores, which are conversions from a donut scale into a z-score scale. All right. So let me do the same thing over here with the numworks calculator. So I need to get out of this stats tab. So I'm going to scroll all the way up to the top, come over to data. Now I want to come over to V2, and this is going to be my z-scores. So if I hit OK, I can fill that column with a formula. I'll hit OK, and I'll just let it be empty. Okay. So now I need to have my X values. So I'm going to have left parentheses first. And V1 is my list of X values. These are the unique datums. These are in my donut scale. So I need to print a V1 down here. So to get a capital V, that's in this division key. So to get a capital V, I have to hit Shift, Alpha, divide. Okay, and then 1. And then I have to subtract my sample mean. Now, with the Texas Instruments, I could refer to that, and I don't think I can, I haven't learned how to do that if you can here. which is why I saved that value into the variable capital M to stand for mean. So to get that back, I need to hit Shift alpha and then 7. So there's my capital M, right parentheses, divided by the sample standard deviation, and I save that in a lowercase s. So to get a lowercase s, I just hit the alpha key by itself, and then the 5. All right, so now if I hit execute, there's all of my z-scores. So if we take 1 on the donut scale and convert that into a z-score, it converts over to negative 1.63. If I take 2 on a donut scale, that converts over to a negative 0.1 on the z-score scale. And remember the mean, the measure of center, the mean was 3. So when you have a mean on one scale, like the donut scale, that becomes 0 on the z-scale. And then a 4 on a donut scale is equal to a positive 816 on the z-score scale. And a 5 on the donut scale converts to a positive 1.63 on the z-score scale. Now let me come back over to the Texas Instruments and let me hit enter. And you see we're getting the exact same values. All right, one other thing to point out here is that the mean of a data set, so the mean becomes 0 on a z-scale. And notice that if we go 1 donut less and 1 donut more, we pretty much get the same value below and above 0. It's just that below 0 it's negative and above 0 it's positive. So in the same way that we're going 1 donut less and 1 donut more, we're going 0.81 less and 0.81 more. So 1 donut on the donut scale is equivalent to 0.81 on a z-score scale. And you can see that as we go 2 donuts lower and we go 2 donuts higher than our average, than our mean, then we're going 0.81 twice and we're going 0.81 twice. But we're going kind of like twice in a negative direction and twice in a positive direction. All right. And to kind of show you that show you something about these two scales, I'm going to graph these, okay, as histograms at least. I haven't practiced this, so this could blow up in my face. Let me let this frequency list of numbers be equal to that one. So I'm going to click OK. I'm going to fill it with a formula. Let me make it empty. And I want N2 to be equal to this frequency list here. So that's going to be Shift alpha N1 like that. Okay, so you can see I took these frequency values and copied them over there. Okay, now I want to graph this. So I'm going to come over here to graph. And it's asking me what kind of plot I want to do. I want to do a histogram. Okay, so it's throwing this off a little bit. Let me see if I can change the settings here. Okay, the bin width, this negative start. This will get me close enough, I think. Again, I'm just kind of winging it. Let me put -2 here. I think that might get me close enough. Maybe with a bin width of 1. Let's try that. Oh, not quite. Okay. These scales aren't exactly the same. Let me try one more thing. Let's try. Again, this is what happens when you try and wing it. Yeah, it's not quite working out. What I was hoping to show, and this is close enough, I'm going to show it on the next screen here, is that, here's the distribution of donuts, and it has this symmetric shape to it. And you'll notice that that same symmetric shape is preserved here on our z-scale. So this is the scale of donuts up above. And then this is the scale of z-scores down below. So the shape is preserved, but this mean of 3 got converted to 0 on a z-scale. So you see here, this is 0 on a z-scale, and that's where this measure of center is. And if we come back up to our donut scale, a mean of 3, this is the center on a donut scale. So if you've done the conversion right, the conversion should not change the shape of the distribution of your data. The only thing that'll be changing is you're just kind of taking all these values and you're shifting them to be centered around 0. All right. And that picture, I think, is better illustrated now on the next page. All right, so here we've got a graph, a dot plot on a scale of donuts. And so you can see this graph here with a mean of 3. And when we take this data distribution and we convert it into a z-score, notice that the shape hasn't changed, right? This distribution shape here has the same distribution shape here on a z-score scale. But this measure of center with a sample mean of 3 on a donut scale becomes 0 on a z-score scale. All right. And a z-score scale is looking at a distance either above or below 0, either above and below our mean. Okay. A donut scale doesn't do it that way, right? Because 0 isn't here. So we are kind of going one donut above and one donut below, but that's represented by a 4 and a 2. Whereas on a z-score scale, because our center of the data is now 0, going up 1 above it is now 1, and going below 1 is now -1. Going up twice is +2, going below twice is -2. Okay. Um, yeah. So what we did is we converted from donuts to a z-score. And so the formula that we used to do that conversion was this one. So z equals x minus x bar over s. So with that, we were able to convert units of donuts into a z-scale. And I guess really quick, we did that on the calculator, but let me show physically what that looked like. So for example, if we wanted to take and calculate a z-score when x is equal to 1, okay, so I've just copied this same formula here. I've just copied it up here. Okay, so what is the value we want to convert? We want to convert when x is equal to 1. So I'm going to put a 1 there. And then x bar, okay, we calculated on the previous screen. That was 3. And the standard deviation, I am going to round just for the purposes of showing this simply. That was 1.225. And if we do 1 minus 3, that's going to give us -2. And if we divide that by 1.225, we get -1.633. So when x is equal to -1, our z-score is -1.663. So let's see where that went. So when we had a value of one donut, one on the donut scale, that converted to negative 1.633, okay, which would be right about here on the z-score. And if we look, well, I included a table of the values here. And so on the calculator, 2 donuts translates to a negative 0.816. So 2 donuts translates to a negative 0.816, just short of negative 1. And 3 on the donut scale, that is our measure of center. That translates to 0 on the x scale. Okay, and we could do the same, calculation by hand that we did with the calculator, as I demonstrated over here on the side. And that's going in this direction. All right, but what if we had a z-score and we wanted to go back to a donut scale? Well, then the equation we're going to use for that is going to be x equals x bar plus z-score times our sample standard deviation. So that'll let us convert from a z-score back into a donut scale. So let's take let's do that. So what if we wanted to calculate what the number of donuts is if we have a z-score of maybe positive 1.633. So now, instead of going in this direction, we want to go in that direction. Oh, sorry. Okay, 1.6. So if z is 1.633, what's that on a donut scale? So our mean was 3. Our z-score is 1.633. Okay, and I don't like squeezing things in here, but our standard deviation was 1.225. I apologize for that. If we simplify all of this on the right-hand side, our value of x on a donut scale when z is 1.633 will be 5 donuts. So a value of 1.633 on the z-score translates to a 5 on the donut scale. So you can see how we can go back this way. So understanding this concept of converting data in just about any unit you can imagine into a z-score, okay, is like a foundational idea that you're just going to see over and over and over and over again throughout the rest of this semester in one way or another. And we won't be converting things into just a z-score. We'll be converting values into a t-score as well, to a t-scale. And then we'll do it for a chi-squared scale and an f-scale. Okay, so getting this idea down and becoming comfortable with it is going to be important. Okay, this is not like you've learned this once this semester and you won't see it again for the rest of the semester. No, this is foundational here. So much so that I've got a number of examples for you to practice with, okay, to get good at it. But in terms of, this example here, I think that this is the end of this example. Let me just close with some notes here that I made at the bottom. So note that the mean in the donut scale, in the sample data became 0 in the z-score scale. So a mean of 3 here ended up being a 0 here on the z-score scale. The original shape of the sample data has not changed. So the shape of the dot plot did not change, okay, when we converted from one scale to another. In the sample data, location of the datums are their distance from 0 donuts, okay? Um, shouldn't be, let's see, oh yeah. Okay, so what I mean by this is in the sample data, ah, in the sample data, the location of the datums are their distance from 0 donuts. So what I mean is you start from having 0 donuts and we went up to 1 donut, 2 donuts, 3 donuts, 4 and 5, right? So this is where 0 was located. In the rescaled data, when we put it on a z-scale, the location of the datums are relative to z equals 0. So this is what I was commenting on earlier, is that now we've got 0 at the very center of our data, and now we're going one value up and one value down, two values up, two values down, two z scale or z scores, I'm sorry, three z scores up and three z scores down. Okay. 0 is now at the center of the distribution on a z scale. Okay. And so in the sample data, each datum was separated in units of donuts. In the rescale data, each datum is separated in units of standard deviations away from the mean. Okay. Okay. So I think that's about all that I want to explain on this example. Again, so I've shown you how to use, both the Texas Instruments, and the NumWorks calculator to calculate or to convert values, into z-scores. And yeah, my little graphing example didn't work out quite as well as I wanted it to, but this general idea here was what I was trying to communicate here better in your student lecture notes. And just notice that as you go from one scale to the other, you can go back and forth. You just have to use two equations that are inverse functions of each other. Okay. All right. So that concludes this definition and example. Let me know if you have any questions.